అడగండి అమ్మా. ఏం డౌట్ లేవా? ఓకే. దిస్ ఇస్ 5x + 1 4x to 200. 5x ఇది 5x1 కాదమ్మా, ఇది ఇక్కడ ఇది 5x 0 తప్పు చేశారు. ఏ రైట్ అర్థమవుతుందా? 030 030 030 50 0 ఇగో 030 ఇగో 030 ఇగో 50 ఇక్కడ రాసినాడు. తర్వాత 025 20 ఇగో 025 ఇక్కడ రాసినాడు. ఇగో 20 ఇక్కడ రాసినాడు. తర్వాత 020
20కి లేదు.
ఓకే చూసి 020 10 తప్పుది గీసాం గ్రాఫ్. ఇది ఇక్కడ రావాలి, ఇక్కడ ఉన్న పాయింట్ ఇక్కడ రావాలి. 020 10 క్లియరా?
క్లియర్.
అయితే ఇట్లా గ్రాఫ్ గీసేసి స్టెప్ 3 ఐడెంటిఫై solution indicated by shade area inside of origin. Find the corner points of the feasible region. A is equal to 20 05 that is D is equal. దీన్ని బట్టి మనం వాల్యూస్ ఫైండ్ అవుట్ చేసాం. డి ఈ కార్నర్ వాల్యూస్ ని మనం ఫైండ్ అవుట్ చేసాం. డి 400/15. ఎట్లా ఫైండ్ అవుట్ చేసాం కార్నర్ వాల్యూస్ ని? కట్ అవుతోంది ఇక్కడ, అవునా
సార్?
అవుతుంది, అవునా? కార్నర్ కట్ అవుతుందా లేదా?
yes sir, yes sir.
ఇక్కడ కార్నర్ కట్ అవుతుంది కాబట్టి వాల్యూ 400/15 500/13 వీకెన్. ఈ రెండింటిని మనం ఈక్వేషన్ సాల్వ్ చేయాలండి.
ఇప్పుడు 8x1 8x2 ఇవన్నా సార్?
కాదమ్మా, 5x1 + 4x2 < 20. ఇంకోటి తప్పది.
అదే అవే సార్. ఇప్పుడు
ఆ రెండు
ఈక్వేషన్స్
x1 x2
yes sir.
This is the one optimal solution substituting corner points of the objective function. అక్కడ పాయింట్స్ రాసాము. సో z is equal 3x1 + x2. పాయింట్ సబ్స్టిట్యూట్ చేస్తున్నాము. given the values may become clear.
yes sir.
సో ABCD. సో z is equal to 1 మొత్తం వాల్యూ వచ్చింది. z is equal to మొత్తం వాల్యూ చేస్తే 800/13 1400/13 the 1800/13 is equal to 138. This is called one graphical method. Okay, just a minute, stay on the line.
Okay sir.
For examples and minimization of LP problems, use the graphical method to following LP problem. 200x1 + 400x2, x1 + x2 greater than ichinda, less than ichinda. Don't worry. First you have to do is equal to. So are you understanding?
yes sir.
3x/. So ఇచ్చిన వాల్యూస్ ని వేసి గ్రాఫ్ ఇగో చూడండి. ఇక్కడ x1 is equal to 0, x2 200, x1 0, x2 అర్థమైందా? గ్రాఫ్ వేసేసారు. డౌట్ ఉంటాడు కానీ ఎందుకంటే 12 యూనిట్స్ మెయిన్ ఇంపార్టెంట్ చెప్పాలి కాబట్టి నేను విడిచిపెడుతున్నాను నేను వీటిని. క్లియర్?
yes sir.
సో ప్రాఫిట్ కాస్ట్ ఈ థియరీ పార్ట్ చదువు. డౌట్స్ ఉంటే అడగండి, నేను క్లారిఫై. Very important. This is theorems vertex point. So in this theorem,
yes sir.
points of the convex set and set of convex combinations, linear dependent and linear independence of vector spaces, fundamental theory of linear programming, some theorems for solving linear programming problems, and check your progress. And with all these one here, you have to study. Yesterday I told that you did not. Vaidehi and Monica not came. Yesterday another 2 people came.
Sir, right.
Yeah, you have to study introduction for objective type questions here. Let us recall.
Introduction, sir.
Yeah, all the introductions you have to learn for objective type questions. Let us recall the graphical solution to the LPP in the previous chapter. We found that problem consisting of two variables. The inequality is determined by the convex polygon. So they will ask in the short question, the inequality is determined a bounded space, which is a convex polygon or a polygon or anything. Any point of which will be safety restriction represent the feasible solution. It restriction represent a feasible solution or infeasible solution. They will ask. Yesterday I told that feasible and infeasible solutions, but all of them not necessarily optimum. The polygon is the set of feasible solution here. In a similar problem, having the three variables by plotting a polyhedron solution space in 3 dimensions may be found, and the desired solution can be obtained in a similar way. But when the number of variables more than 3, these cannot be plotted anymore. Extending the same logic, the optimum solution of LPP involving, I am asking the short question, the optimum solution of linear programming involving dash variables can be found under small n variables you have to write here. A solution space is determined by the boundaries corresponding the restrictions of the problem, and this polygon is end. The polygon has some extreme points, one of which optimum solution. The extreme points are called the basic feasible solution. The extreme points are examined to find out one of each objective function attains the optimum value. Lines and hyperplanes and convex sets. In R power n, the line through the distinct points x power 1 and x power 2 is defined the set of points. What is the line? So they will ask x is equal to, in the lines, x is equal to, I will ask x colon x power lambda x square 1 minus lambda for all read lambda. You have to write this equation where the lines passing through the vectors x power 1 and x power 2 and parallel to the vector. I will ask if the plane in the plane whose position vector x power 1 and x power 2 and it's parallel to the vector dash x power 2 minus x power 1. Are you clear?
Yes, sir.
R power n, the line segment joining 2 x1 and define that the set of dash, it's the points. You have to write that one. All these are smart bits I am telling now in this unit. Hyperplane has the equation d1 x1 and d2 x2 is equal to z, represents the line r square. The prescribed value of d1 d2 z, d1 x1 d2 x2 d3 x3 is equal to z is the equation of the plane in r cube. In the similar fashion, we can say that point satisfying d1 x1 and plus d2 x1 so on dn xn is equal to z. Not all da is equal to 0. Therefore, dx is equal to z or d power t x is equal to in matrix form. Define a hyperplane for prescribed d2 dn. Values dash for optimum of value of z. This hyperplane is called as optimal hyperplane. You can write here d1 d2 dn. So you have to study all those points. You can write down all questions. Clear?
Yes, sir.
Closed off space. I will ask closed off. What is the closed off space? You have to write the set of x1, x less c, x less than z, and x3, c of x greater than z are closed off space. Convex sets you have to study here. I'm not going to the convex sets. This is the convex sets. Non-convex sets ante itla untai. Anni fill ayi untai. For example of convex sets, non-convex sets emo itla fill gakunda untai. This is the convex sets. So I'm not. You have to write. Study the convex sets. Then extreme point of convex set and convex combination vectors. So extreme here, points of convex set A, point of X is convex set C is called as our extreme point of X. Cannot be extended. Non-trivial, not trivial, non-trivial convex combination of any two distinct of I1 and Y2 in C. Mathematically, Y point is an extreme point of convex set if do not exist other point Y power 1, Y power 2. Y power 1 not equal to Y power 2. The set such that lambda into Y power 2 1 minus lambda 0 less than lambda less than 1. I will ask what is the properties of extreme point in short bits. You would write an extreme point cannot be between 2 points of the set. An extreme point is a boundary point of the set. Not all bounded points is a convex set necessarily extreme points. Same boundary points may lie between 2 other boundary points. You have to write here this convex set. I'm not asked about thing. There's a linear vector. Is the very most important. Linear dependence and linear independence of vectors. Basis. Linear dependence, a set of n-dimensional vectors v1, v2, vn is set. What is meaning of linear independent?
Sir.
What is the meaning of linearly independence? In a linear algebra, you can learn in the 5th semester. Linearly independent means what? Vectors. See here, linear dependence and independence, a set of n dimensional v1, v2, linearly dependent constant. And what is the alpha 1, alpha not being equal to 0 can be found. Alpha 1 v1, alpha 2 v2 plus alpha n vn is equal to 0. Equivalent to student theta is equal to alpha 1 is equal to alpha 2 is equal to alpha n are called linearly independent. Correct or not? Linearly independent and equal అవుతున్నాయి అవునా కాదా?
Yes, sir.
Basis for a vector space. నేను ఇవన్నీ చెప్పేది షార్ట్ క్వశ్చన్స్ కి స్మాల్ బిట్స్ కి. The basis for a vector space is a set of linearly independent vectors such that vector space can be expressed as a linear combination of this set. The vectors in such a set are called as the basis. So see here, a basis of a vector space is a set of linearly independent vectors such that any vector in the vector space can be expressed in linear combination of this set. The vectors in such a set are called the basis vectors. V1, V1, 1, 0, V2, 0, 1, 1, 0, 0, 1 we are taking here. The basis vectors of the two-dimensional vector space. The two-dimensional vector space we can write here x V1 and y V2. X V1 is 1. That is x V1 and y V2. There is 0. We did not take in that is xy values are I'm applying. So V1 V2 is equal to 1, 0, 0, 1. Correct or not?
Yes, sir.
1, 0, 0, 1. By the R3 dimensional matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So we are applying here one basic matrix here 302 709 412. So by example verify that 302 709. So lambda 1 A1 A2 So A1 302, A2 709, A3 412. Consider the equation lambda 1 A1, lambda A2, lambda 2 A2, lambda 3 A3. So multiply them 3 lambda 1, 7 lambda 2, 4 lambda 3. Correct? 0 lambda 2, 0 lambda 1, 0 lambda 2, and 1 lambda 3 is equal to 0. And 2 lambda 1, 2 lambda 1 plus 9 lambda 2.
2 lambda 3.
2 lambda 3. ఇక్కడ మిస్ అయింది అది ఈక్వేషన్ మిస్ అయింది కనుక్కుంటాం lambda 1 lambda 2 lambda 3 వాల్యూస్ ఫైండ్ అవుట్ చేస్తాం క్లియర్
Yes, sir.
lambda 1 0 lambda 2 0 lambda 2 3 0 so therefore it is dimensional the basis for r cube మేము 5th సెమిస్టర్ లో లీనియర్ ఆల్జీబ్రా లో నేర్చుకున్నాం మనం క్లియర్ Next example, determine whether vector 1, 2, 3 is a linear combination of the vectors 1, 2, 1, 1, 1, 2, 3, 2. So multiply the same here. K1 plus K2, 2K3 is equal to 1. 2K1 plus K2 plus 3K3, K1 plus K2, 2K3. Find out చేస్తే మనకు అన్ని జీరోలు వస్తే అది డైమెన్షన్ లేకపోతే నాన్ డైమెన్షన్ అవునా కదా డైమెన్షన్ లో వస్తుంది ఎందుకు చెప్పనా K1 plus K2 plus 2K3 ఫస్ట్ లాస్ట్ మొత్తం అన్ని క్యాన్సిల్ అయిపోతే ఏముంటదమ్మా
మిడిల్ ఉంటుంది
ఫస్ట్ ఈక్వేషన్ థర్డ్ ఈక్వేషన్ ఆర్ కాన్స్టెంట్ సో వి కెనాట్ ఫైండ్ K1 K2 K3 చేస్తదా K1 K2 K3 ఫైండింగ్ so linear combination of the three vectors fundamental theorem of linear programming the collection of feasible solution of LP problem constitute a convex set whose extent corresponds to the basic feasible solution. Let G be a set all feasible solutions of system AY is equal to B, BY greater than 0. The set of G solutions has only one element then G is a convex set. Hence, theorem is true. In this case, now assume that there are at least two distinct points, y power n, y power 2 in G. Then we have a y power 1 is equal to b for y greater than 0, a y power 2 is equal to b for y square greater than 0. We only need to show that every convex combination feasible solution is also feasible solution. We define a new point. Just a minute. So see here, we define a new we define a point here. So the collection of the feasible solution of the LP problem here to the. I'm audible?
Yes, sir.
The collection of all the feasible solution to the LP problem constitutes a convex solution. Extend the points correspond to the basic feasible solution here. So Ay is equal to b, y greater than 0. The set of solutions has only one element, then G is a convex set. Since the theorem is true, in this case, now assume that there is at least two distinct points, y power and y power 2 in G. Thus, we have here, then a y power 1 is equal to b for greater than 0, and y is equal to 0, and a power y2 is equal to b for y square greater than or equal to 0. We also need to show that every convex combination of any two feasible solutions also a feasible solution. We define a new point here. Y power 0 at the convex combination, y power 1 and y power 2. So this implies that y power 0 is equal to lambda y power 1 minus lambda y square, 0 less than or equal to y, lambda less than or equal to 1. So by the definition, G is convex. If y power 0 also G, we show that we must show that satisfies the system of constraints y is equal to b, y greater than or equal to 0. A power y0. A y power 0 is equal to a within the a bracket start lambda y power 1 minus lambda y square, a lambda a y power 1 minus lambda a power y square. This is the all short bit questions you have to study by this definition, the fundamental theorem of LPP. So some of the theorems for solving this is the most important theorem. In the convex set of feasible solution, ay is equal to b greater than 0 in the convex polyhedron. So therefore, at least of the extreme points is given optimal solution. In the optimal solution occurred that the more than extreme point here. So the values of the objective function will be the same for all the combinations of these extreme points. First part, let y power 1, y power 2, and y power k be the extreme points. The feasible region is the of the G of the LP problem. Z is equal to Cy subject to Ay is equal to b y greater than 0. Suppose y power m is the extreme point. I am asking the LP problem. In the LP problem, I will ask some of the theorem of the linear. The convex set the feasible solution a by b is equal to 0. Dash is the convex polyhedron. So you have to write this one. And also y power 1, y power 2, y power k, which is the value of the objective function. Then z star is equal to maximum of Cy whole power t, Cy whole power m. So t is equal to 1 to k. We now consider a point y power 0 in which is not an extreme point, and let 0 be the corresponding value of the objective function. Then z power 0 is equal to Cy power 0. Since y power 0 is not extreme point, it can be expressed as a convex combination of the extreme points. Y power 1, y power 2, and y power k of the feasible region where G is assumed to be a bounded set here. So therefore, we are writing these one z power 0 is equal to C power y0. Therefore, lambda power 0 is equal to lambda 1 power y power 1 plus lambda 2 y power 2. And so on lambda k y power k. So lambda 1, lambda 2, and lambda I greater than is equal to 0. Summation of I is equal to 1 to k, that is lambda I is equal to 1. Thus, the substituting these values here, we get here z power 0 is equal to C lambda 1 y power 1 plus lambda 2 y power 2, and so on lambda k y power k less than or equal to y power m. So this is the implies here, since C of y power m we are taking here. Why the substituting the value here? Why? Because lambda 1, lambda 2, and the lambda I is greater than 0. Then only we can write in here z power 0 is equal to C lambda 1 y power 1 lambda 2 y power 2, and so on lambda k y power k less than or equal to ym. So which implies that the optimum solution, the extreme point solution, is at least as good as other feasible solution. The second part, let y1, y2, y1, y power 1, y power 2, and so on, y power r less than k, the extreme points of the feasible region G at the which objective functions assumes the same optimum value. This means z star c power y, c, y power 1 and c, y power 2 and so on is equal to c, y power r. So what is the constant and y power 1 and y power 2 and y power, the constants we are taking here. So further the optimum solution, the further let x equal lambda 1, y power 1, lambda 2, y power 2 and so on, lambda power r, y power r. Lambda 1, lambda 2, lambda power r, lambda r greater than or equal to 0. Summation of I is equal to 1, summation of I is equal to 1. So lambda j is equal to 1 with a convex combination. The constant of cy1 we are writing here y power 1, y power 2, y power r. I'm taking cy is constant here. Already I told you. See, I'm taking common here. Lambda 1 and y power 1 and lambda 2, y power 2 and so on, lambda r, y power r. So lambda 1 cy power 1, lambda 2 cy whole power 2, lambda r, c power r we are taking here. Lambda 1 plus lambda 2 so on plus lambda r z star. So therefore cy is equal to z star. So summation of I is equal to g1. ఏం చేయట్లేదు, కాన్స్టెంట్ బయటికి తీసుకొస్తున్నాం, కండిషన్ సాటిస్ఫై అని చూపిస్తున్నాం. కండిషన్ సాటిస్ఫై అయినప్పుడు సమ్మేషన్ ఆఫ్ j is equal to 1 or lambda j is equal to 1 అని చూపిస్తున్నాం. Clear? Any doubt? Okay. Second part clear. And theorem 5. The set of all feasible solutions of linear programming problem as a convex set. Let S be the set of all feasible solutions of the problem x is equal to b for x greater than 0. If S has only one element, then S is a convex set and the theorem is true. Let us assume there are at least two distinct feasible solutions, x1 and x2. Therefore, ax1 is equal to b, x1 greater than 0, x2 is equal to b, x2 greater than 0 here, what we are writing here. Let x be a convex combination x1 and x2 here. X is equal to ax1 plus 1 minus x2 for 0 less than a less than 1. So x1 greater than 0, x2 greater than 0, 0 less than a less than 1 we are taking here. So therefore x is also greater than 0 for stands to 4. What the conditions what we are taking here? X is equal to a of ax1 plus 1 minus ax2. So therefore the simplification of a into capital ax1, 1 minus a, ax2, ab plus 1 minus ab using 1 and 2. Therefore b is equal to 5. For 4 and 5 the above conditions here, x which convex combination to feasible solutions also. అంటే మనం ఏం చేయట్లేదు, ఇచ్చిన ఈక్వేషన్ 1 2 ని తీసుకొని వాటిలో x1 x2 వాల్యూ 1 మైనస్ a సబ్స్టిట్యూట్ చేస్తే మనకి b వాల్యూ వస్తుంది. అప్పుడు ab వాల్యూస్ ను ఫైండ్ అవుట్ చేసి కాన్వెక్స్ కాంబినేషన్ అవుతుందా కదా, టూ ఫెజిబుల్ సొల్యూషన్స్ వస్తాయా లేదా అని ఫైండ్ అవుట్ చేస్తాం. క్లియర్ ఆ వైదేహి? ఓకే, clear? Okay. The objective function takes its maximum or minimum value at on extreme point of the convex polyhedron generated by set of feasible solution. Let the extreme points 1 minute. The objective function takes minimum, maximum or minimum value at an extreme points of the convex polyhedron generated by the set of feasible solution. Let the extreme points of the convex polyhedron denoted x1, x2, x4, 6 be the objective function. The values of the objective function at the extreme points are cx1, cx2, cx3 and cx4. Let the maximum of these extreme point solution cxm, let its x not be a point inside the polyhedron where the objective function attains a maximum. Cx0 less greater than Cxi for all I. Since x0 is not extreme point, it can be expressed as a convex combination of the extreme points. So therefore x0 is equal to a1, x1, a2, x2 and so on. Xn, ai's are x greater than or greater than 0. A1 plus a2 and so on plus an is equal to 1. Substituting in the objective function which is linear. So Cx is equal to, I'm taking the C is constant here, a1 x1 and a2 x2 and so on plus an xn. What we are taking here, so multiplying this constant a1 c x1, a2 c x2 and so on, an c xn. So it is equal and less than or equal to also A1C x1, A2C, A less than or equal to A1C xm, A2C2 xm, ANC. అంటే ఇక్కడ x1 place లో xm వాడతాం, less than or equal to common is A1 plus A2 and so on. Is the AM, so therefore less than or equal to CXM. But we have assumed that here Cx greater than 0, Cxi for every I, Cxi greater than 0, Cxm. So Cx0 greater than Cxm, Cx0 less than xm. So this can be truly అంటే మనం A1C x1 రాసుకున్నప్పుడు మామూలు తీసుకుంటాం, తర్వాత less than or equal to తీసుకున్నప్పుడు xm కండిషన్ తీసుకున్నప్పుడు Cx0 greater than Cxm రాసుకుంటాం. So therefore Cx0 is equal to Cxm. There is no extreme point x power m, which is the objective function, attains maximum. The minimization is extremely similar here. You have to check here. Then we will go to the slack, surplus, artificial variables. Slack, surplus, artificial variables. By the time of define the slack, surplus and the artificial variables for LPP. Determine the LPP into a matrix form. Obtain the optimal solutions to solving the LPP by simplex method. In the previous unit, we have discussed the graphical methods theorem related to the optimal vertex point here, which is limited to provide solution of LPP. It is not possible to obtain the graphical solution to the linear programming problem of more than 2 variables. More than 2 variables to solve element. So the analytic solution is also not possible because the tools of analysis are not well equipped to handle inequalities. The most commonly used method for locating the optimal vertex in simplex method, which is developed by the simplex method, who is developed G. Downsing in 1947. The simplex method provide algorithm, a rule of iterative procedure based on the fundamental theorem of linear programming. We need to convert the given LPP inequalities to establish by introducing slack, surplus, and artificial variables. We start this method with matrix representation of LPP and obtain optimal solution for LPP here. Then slack, surplus, and artificial variables. Slacks, surplus, and artificial variables here. The general linear programming tools find a vector to set off values x1, x2, xn, which maximizes the objective functions here. Z is equal C1 x1 and C2 x2 and so on. Cn xn here. Z is equal C1 x2, C2 x2 and so on. So Cn xn here. So we are writing in the matrix formation here, subject to linear concentrations A1 11x1, A12 x2 and so on 1 xn. So 1 xn. And a matrix formula రాసుకుంటాం. Matrix formula రాసుకుంటే less than or equal to or greater than or equal to B1. A21 x1, 22 x2 and so on at 20 xn less than or greater than B2. 31 x1, 32 x2 and so on 30 plus A13 xn అది కూడా less than or greater than B3. అంటే ఇక్కడ నాన్ నెగటివ్ కండిషన్స్ ఉంటే xi j greater than 0, j is equal to 1 2 3 అని కూడా రాసుకుంటాం ఎప్పుడు స్లాక్ వేరియబుల్స్ లో. So what is slack variable? We will ask the short defined question, what is the slack variable? We know that the constraints of the linear program. Constraint means 2x plus 1 3x2 greater than 0, 5x plus 1 4x2 greater than 0 or less than 0, 5x plus 1 4x1 greater than 0 is the condition of x1 greater than 0, x2 greater than 0. This is called as constraints. So see here, so we know that the constraints here A11 x1, A12 x2, AM xn C1 equal to 1. The convert the equation we can be added. Already in the problem of graphical method, less than or greater than then is equal to C1 and colony A11 x1 plus A12 x2 and so on AM xn plus S1 is equal to 7. Clearly S1 greater than 0, the variable is called as slack variable because slack means the requirement minus production. Example, consider equal to 2x1 plus 4x2 plus x3 9x4 is equal to 17 is equal to 17. S1 less than 0 or greater than 0? Monica, this is S1.
Yes,
suppose S1 is greater than 0. Why? Because in the values 0 substitution already 6 9 15 వస్తుందా లేదా?
17, no, sir.
అవునమ్మా,
Yes,
17 minus
sir.
15 ఎంత అవుతుందమ్మా?
It's greater than 0, sir.
Greater than 0. The surplus of variable of artificial variable here. Then the consistence of the linear programming problem of the inequality greater than or equality B11 x1 plus B12 x2 and so on B1 n xn less than. To convert the tell me Monica.
1 minute, sir. 1 minute.
1 minute.
Sir, sorry. Sir?
Monica, tell me. Monica.
Yes, sir.
Your voice is not clear. Your voice is not clear. So, no, asal వినబడడంలా మొత్తం కట్ అవుతుంది. The constant of linear programming problem B11 x1 B2.
Is it okay?
Huh? Monica, tell me.
Yes, sir.
Now clear.
I was using my headset, sir. That's why it's not clear.
B1n xn అంటే మనం ఏం చేస్తున్నాము, స్లాక్ వేరియబుల్ లో వచ్చిన దాంట్లో 0 ఏదో సబ్స్టిట్యూట్ చేస్తే అది లెస్ దాన్ 0 అవుతుందా గ్రేటర్ దాన్ 0 అవుతుందా కనుకుంటాం. శివారెడ్డి క్లియర్?
Clear, sir. Greater than 0 on.
అంతే. S2 ఇక్కడ కూడా అంతే. S2 is equal 0. The variable called as surplus variable. Surplus is equal production of requirement. మైనస్ చేస్తున్నాం, వచ్చిన దాంట్లో మైనస్ చేస్తున్నాం. అక్కడ ఇక్కడ ఏం చేస్తాము, ఏ చేసాం, ఇక్కడ బి చేసాం. సో ఎగ్జాంపుల్ చూడు, 5x1 plus 7x2 plus 9x30. సో ఇక్కడ గ్రేటర్ దాన్ అంటే ఏం చేసినాము, 0 సబ్స్టిట్యూట్ చేసినాడు. ఇక్కడ A1 తీసుకున్నాడు, ఇక్కడ సర్ప్లస్ వేరియబుల్ A1 తీసుకున్నాడు కాబట్టి S2 S2 is surplus, A1 is artificial variable. అంటే స్లాక్ వేరియబుల్ కి ఆర్టిఫిషియల్ కి మధ్యలో ప్లస్ యాడ్ చేస్తున్నాం. A1 యాడ్ చేసిన అది గ్రేటర్ దాన్ 0 అయితే మాత్రమే అది ఆర్టిఫిషియల్ వేరియబుల్. క్లియర్?
Clear, sir.
Surplus variable and artificial variable. Now clearly artificial variable. The constant of LPP to be converted into the form of equation, we must introduce new variable on the left side of equation. So D1 x1, D2 x2, D3 x3, and so on. Dn xn is equal to Ck. We added artificial variable. A1 greater than 0 is artificial variable. So suppose we can take the example here: 2x1 plus 3x2 plus 4x3 is equal to 9. So 2x1 plus 3x3 plus 4x3 plus A1 is equal to 9. So the unequal, so we have to write this artificial variable here. Plus A1 add, this is called as artificial variable. The constant in the artificial variable as the inequality less than add slack variable. Add slack variable, then equality less than subtract surplus variable and artificial variable. The inequality is equal to we add only artificial variable. These are conditions I will ask in the short bits.
That note point, sir.
I will ask in the who is the ask in the examination question paper. What is artificial variable? The inequality less than, the inequality greater than, the inequality is equal to. You will write artificial variable, surplus variable, and artificial variable. Add slack variable. Shivaredi, clear?
Clear, sir.
Government now joined. What you will understood in the middle of the class? What matrix representation of LBP? The general form of LPP is given below. Z is called C1 x1, C2 x2, C3 x3, and so on xn. A1n xn less than or equal to R less than or equal to B1. So see here, A21 x1, A22 x2, and so on 20n xn less than or greater than or B2. ఇంతకుముందు చెప్పుకున్నట్టుగానే up to AM1 x1 and up to AM2 x2 and so on place AMN xn less than or equal to R BM. The objective function Z is maximize and minimize subject to constant rate where x1, x2, n, the decision variables whose values are to be found, x1 greater than 0, x2 greater than 0, xn greater than 0. It can be put as summation z is equal to summation of j is equal to n, cj, xj. I am telling this is not a proof, just objective type questions you have to bring here for the short questions. For xj greater than 0, j is equal to 1 to n. Now the matrix representation LPP, it is x is equal to x1, x2, xn plus 1 plus n1. So therefore x is equal to b greater than 0. Already told this theorem, the objective function. Told or not?
Yes, sir.
You have to, I am told here, so therefore b greater than 0 constant equation, x greater than 0 is non-negative restrictions here. So x is equal to x1, x2, xn and xn plus 1 and so on, xn plus m. So C is equal to C1, C2, Cn is 0, B is equal to B1, B2, Bm. Here I am writing in the matrix form. A11, A12, A13, An, A21, A22, A23, A20n, A M1, M2, M3, AM 100, 0100. What is this method? You know that in your what is Gauss-Jordan method? Method we have to write the same form.
Sir?
In Gauss-Jordan method also we are write the same method. Matrix form.
Yes, sir. Yes, sir.
This form may be written as this one. So the vector denotes the vector, gives the corresponding coefficient of the objective function. The coefficient of the slack variables are 0. So therefore the vectors of contingent variables and slack variables. See here, very simplex algorithm. The table is most used. Tell me. Tell me. Monica asked me.
Yes, sir.
Any doubt?
No, sir. Not yet, sir.
So simplex algorithm, simplex table, CB1, CB2, CBM, basic variable x power n plus 1, x power n plus 2, x power n plus m, XB, XB1, XB2 and XBM, that is called CBI, XJ. C1, C2, ఇంతకు ముందు రాసింది A11, A12, A21, A22, XN, A11, 10, తర్వాత ఇది N1 అమ్మ, ఇది 11 కాదు, ఇది N1, N2, క్లియరా?
Clear, sir.
N1, ఇది N2, ఇది MN, 1000001, minimum ratio ఏం లేదు. So see here, Z minus 1, Z2 minus Zn minus Cn, last Zj minus Cj. So see here, very important. The steps of the computation of the optimum solution are: express the linear programming problem standard from introducing slack, surplus or artificial variables here. Inequality, add slack variable, convert inequality as equation. Inequality greater than or equal to subtract surplus variable and add artificial variable, then inequality gets converts to equality. In inequality, only introduce artificial variable. Right coefficient of the slack, surplus variable are 0. Artificial variables m in the objective function. The standard form of linear programming problem is the expression of form matrix form. Ax is equal to b, where a is the coefficient of matrix, x, b are the column vectors here. So Zj is equal to Cj is the most important here. Consider the simplex table initially as shown above the linear programming problem here. Calculate the Zj minus Cj, j is equal to 1 to n. To obtain the value Zj, multiply each element under the column of xi with the corresponding element under cb column. Zj minus Cj, very important. Zj, see here, delta j, Zj minus Cj greater than 0 for all the optimal solution. I will ask what is the delta j for the optimal solution? Zj minus Cj greater than 0, delta j is equal to 0. Clear?
Yes,
Clear?
sir.
The exam in that one, so that it is optimal solution here. Zj minus Cj is negative, greater than less than 0 some j elements, less than 0 the solution is unbounded, the stop iteration process. The Zj minus Cj is negative, less than 0, at least 1, the solution is optimal and improved solution. The mode very important, you have to study. Then Zj minus Cj greater than 0, there are more than one Zj minus Cj, then choose the most negative of Zj minus Cj minimum. Zj minus Cj less than 0, the variable xk corresponding to zk minus ck will enter to the basis variable, put awards the arrow symbol. Compute the replacement ratio xbi by aak greater than 0 and choose the minimum of them here. Let the minimum of the ratios x br by ark in the variable xr will be the leave the basis. Here ark, which is the rth and kth column leading the element here. You have to study here to compute the improved and revised simplex solution here. If the pivot is the one, row remains the same in the new table also. If the key element is other than the one, then divide each element in the key row, includes bj also, by the element to by current values of the row. Perform elementary row operations on all elements of the simplex table to obtain current values. So get zeros remaining entries of the column pivot element. Perform other elements except key row and key column table. That is a new. We have to write this formula: old element minus corresponding key row element and correspond to key column element by key element we have to we have to take that one. Now repeat the process described the simplex table until zero వచ్చేదాకా మనం చూడాల్సి ఉంటుంది. So write the optimal solution by substituting the values xj in the bijective function. They will ask in the short question working rule for simplex method for solving LPP. All of you listening?
Yes, sir.
What is the working rule method of solving? These 7 you have to write. Formulate LPP in standard form. Standard form ante dabba veyali, table veyali, A11, A2, A3 rayali, enduloki edi teesestamo rayali. Step of the initial simplex table with slack or surplus variables. Identify the decision variables where we brought the solution. Examine the variables to be replaced. Ekkada kaluputam, ekkada teesestam. Calculate the values of the simplex table entering the variables. Do the same remaining rows. Unnaya leda. Check the optimality condition. Right, the optimality avutunda leda. Ee 7 condition. Clear?
Yes, sir.
Then this is also very most important. Simplex method flowchart. Design or design simplex method flowchart and adutam. Place the given LPP into standard LPP maximization type. Itla chestam. Danni em chestam tarvata initial basic feasible solution loki marustam. Avuna?
Yes, sir.
The next evaluation delta j ki marustam. Rasin tarvata observe the row wise addam net valuation chestam. Compute the new simplex table with matrix operations chestune row wise chestam. Chestu examine for only negative na positive na chestam. Negative lekondi appudu reach the optimum solution. Negative lekapothe direct answer vachinante. Otherwise terminate the negative unnadi anukondi teeseskuntu ravali. Avuna?
Yes, sir.
Appudu negative unda yes undi anukondi select the most negative values delta j that non-basic variable solution. Verify whether all concentrated of the entry having the negative value. Then there will be an unbounded solution to the LPP. A new simplex table drawn, delete the outgoing variables from the basis, enter the incoming variable, choose the minimum of such ratios that the basic variable is the outgoing variable, take the opposite coefficient and divide the errors corresponding the values of the basic variable. Student, no problem. Z is called 16x1 plus 17x2 10x3 1 by 20x1 1 by 20x2 1 by 5x3 less than 100 x1 by 10x1 1 by 22x2 1 by 22x3 less than 80 1 by 20x1 equal to 1 by 20x1 1 by 1 by 10x2 1 by 10x3 less than 20 x1 less than 30 x1 x2
Sir, x1 is not there, sir, in the second step.
x1 x2 to x3 x1 x2 x3
Not that, sir. They're 1 by 20 into x1, no, sir.
No, this is another. This is another. Third
No,
one,
sir,
third.
the step above that, it's given that x1 by 10 into x1, x1 by 10 into x1. It's given like that.
No. In the third equation, 1 by 20 x1, 1 by 10 x2, 1 by 10 x3.
Yes, sir. Second one, sir.
This is 1 by 10 x1.
Yeah, that's what, sir.
This is 1 by 10 x1. So see here, first one is what we are writing x1 plus x2 plus x3 by x1 plus x2 x3 by 20 plus 20 plus 5. We can write it or not? x1
Yes.
plus x2 plus x3 by 20 plus 20 plus 5. x1 plus x2 plus x3 by 20, x1 by 20, x2 by 20, x3 by 5 less than 100. So we can take here x1 plus x2 plus LCM this to 4x3. Avuna?
Yes, sir.
4x3 greater than మిగిలిన దాంతో మల్టిప్లై చేస్తే 20 కదా 20 into 100 2000 అవునా
Yes, sir.
Yes, sir.
తర్వాత x1 plus x1 by 10 x2 by 20 1 by అంటే ఇక్కడ x1 by 10 x2 by 20 ఇక్కడ చూడండి అప్పుడు ఏమైతుంది 20 తీసుకుంటే 2x1 plus x2 plus x3 less than or equal to 20 అంటే 20 into 180 ఎంత 3600 x1 by 20 x2 by 10 x3 by 10 మళ్ళీ 20 LCM అంటే ఎంత x1 plus 2x2 plus 2x3 20 అంటే 2400 క్లియరా
Yes, sir.
చూడండి అప్పుడు x1 గ్రేటర్ దాన్ ఎంత అన్నాడు ఫస్ట్ వన్ 30 x1 less than or 30 x2 x3 greater than 30 0 x1 less than 30 x1 less than or equal to 30 అన్నాడు కదా సో
Yes.
కన్వర్టింగ్ ఇన్ఈక్వాలిటీ ఇన్ x like x1 s2 0 ఇక్కడ ఏమి ఇచ్చిండు x1 plus x2 plus 4x3 ఎంత ఇచ్చినాడు
2000, sir.
2000 ఇక్కడ రాసుకో ఇక్కడ
3600, sir.
3600, sir.
పెట్టి 6 మార్కులు ఇక్కడ
2400, sir.
2400.
see here x1 plus x so therefore x1 x2 x3 is over then second function x11 what is they given here 30 x11 plus s4 means 3 is over s1 s2 s3 is over so I'm writing x11 plus s4 is equal to 30 x1 x2 s3 s1 s2 s3 4 greater than 0 x1 x2 x3 greater than 0 అన్నాడు కాబట్టి ఇక్కడ x1 x2 x3 greater than 0 అన్నాడు కాబట్టి so I'm writing x1 x11 plus s4 is equal to 0 here so మనం ఫైండ్ చేయాలండి ఇవన్నీ ఫైండ్ చేయాలి x1 x2 x3 ఫైండ్ అవుట్ చేస్తే x1 0 x2 0 x3 0 వచ్చిందట క్లియరా
Okay.
చేస్తారా
Find initial basic.
నేను అడిగింది చెప్పండి అమ్మా నాకు ఈ x1 x2 x3 వాల్యూస్ ఫైండ్ అవుట్ చేయాలి
They are asking to put the x1, x2, x3 values as 0, no, sir?
find the initial basic cell x1 is equal to 0 minus x2 is equal to 0 x3 is equal to 0 so
Yes,
we
sir.
yes we will do also same on we obtain s1 is equal to 2000 s2 is equal to 3600 అవును
Yes,
0
sir. X is equal to 2400, S4 equal to 30.
and maximum z is equal to 0 maximum z is
Z.
equal to 0 now express the above standard linear programming problem ax is equal to b x is equal to x1 x2 s1 s2 s3 x1 s2 s3 so ఎంత వచ్చిందండి s1 ఎంత వచ్చింది
S1,
2000, sir.
2600 2400 s4 30 s4
S4
30 s4 30 కదమ్మా
అవును,
Yes,
sir.
రాసుకుందాం అక్కడ
S4 కూడా ఇంక్లూడ్ చేయాలి సార్ అక్కడ S4 ఇయలే కదా సార్
ఇవ్వకపోయి అంటే జస్ట్ మనం రాసాం అంతే s4 s5 ఇవ్వకపోయినా రాసుకోవాలి మనం ఎన్ని వస్తాయి వాల్యూస్
ఓకే ఓకే
అండ్ a is equal ఇగో చూడండి 114 రాసినామా
ఎస్ సార్ 1 1 4
1141
0
1141 పక్కన పెట్టండి 2111 2111 రాసినామా
ఎస్ సార్ 1 2
122
1
122 తర్వాత 100
yes
100 s4 రాయం కాబట్టి 100
yes sir
అంటే ఇది మ్యాట్రిక్స్ ఫామ్ కాబట్టి why we are writing here s1 s2 s3 100 010 0010 001 clear
yes sir
Yes, sir.
what is the problem here where is objective function of maximum z is equal 16x1 plus 17x2 plus 10x3 ఎట్లా వచ్చింది 16x1 ఎవరు చెప్తారా
అది డెల్టా వాల్యూ లా చేయాలా సార్
శివారెడ్డి
Sir.
16x1 ఎట్లా వచ్చింది ఇక్కడ ఇచ్చాడు ఎట్లా వచ్చింది అని అంటే డెల్టా చేస్తుంది ఇగో ఇక్కడ ఇచ్చాడు z is equal
Z is equal to 16x1 plus 17x2 plus 10x3, sir.
ఇచ్చాడా
Yes, sir.
0 0s1 0s2 0s3 is 4 ఇవ్వలేదు
అవును, sir.
ఇక్కడ దాకా ప్రాక్టీస్ చేయండి కన్స్ట్రక్ట్ ది ఇనిషియల్ టేబుల్ రేపటితో కంటిన్యూ చేస్తా
Okay, sir.
ఇది మీరు ప్రాక్టీస్ చేయాలి ఇక్కడ దాకా ప్రాక్టీస్ చేసుకోండి ఐ విల్ కంటిన్యూ టుమారోస్ క్లాస్
Yes, sir.
రైట్ అమ్మా
Yes, sir.
గుర్తుపెట్టుకోండి ఎక్కడ ఏ ప్రాబ్లం అనేది గుర్తుపెట్టుకోండి థర్డ్ యూనిట్ లో ఐ విల్
Please
టెల్ టుమారో. ఓకే, థ్యాంక్ యూ.
Thank